So there's the base region. Let R be that region. 0, 0, H0, HR. R and H are constants. Which of the following gives the volume of the solid generated when that region is revolved around the x-axis? So there's my x-axis, or my axis of rotation. I'm going to mirror the shape across first. And then I like to draw the circles in, at least one of them. Help visualize what this thing looks like. So let's go with our template again. Pi big R squared minus pi little r squared d something, and then we'll find that x or y first, and that'll sort of guide us the rest of the way. So are these x slices or are they y slices? Definitely x slices. In fact, that slice nearly perfectly matches my my CD right there. How nice is that?
That one just has a hole in it.
Right. CD has a hole in it. That does not have a hole in it. Let's back up. Get ahead of ourselves. So dx, we're slicing along the x-axis, which means all of everything needs to be in terms of x now. What about the limits? 0 to h. There's got to be x limits. Is this a disk or a washer? Is there a hole or not? No hole. Solid, so I don't have to worry about the little r. Or little r is 0 if you want to phrase it that way. Right. Big R is the distance from the axis to the outer edge. And we can do top minus bottom. I mean, some of you are going to get to the point where you just look at it and you know what it is, but slow it down a little bit here. Top minus bottom. Bottom 0. But this top, I need an equation for that. So this one's a little bit crazy because I don't have an equation for that.
Well, finding that slope would be just to rise over run.
So it'd be rise over run. Oops. R over H times X. So that's the equation of that line because it doesn't have a y-intercept, or the y-intercept is 0. So there's my R. So when I plug that in for R, R over H x squared dx. And some of you were crossing these out as we went. Like, there's no way it could be 0 to r and dx. Like, those don't match, so that's out. Then it's just a matter of the slope is y over x, so that would be d. All right. Feeling a little better about these? Let's look at the notes page. Go to 1D. We did 1A and B yesterday. Let's skip down to D. On the volume of the solid formed by revolving R around the y-axis. Maybe we need to back up a little bit. This was y equals x squared, x equals 2, and y equals 0. So there's our R, our base R from Tuesday. Okay, now I'm going to revolve it around the y-axis. So I'll mirror it across the y-axis first. As best I can. Well, they help me a little bit with starting to curve that direction. Some people stop there, they fill in the template, and they're good. I really like to see the circles on there, just for my own preference. If you don't like the circle, that's fine. You don't have to draw the circles on there. But I think that helps me visualize what this shape looks like. Somebody want to verbalize what that shape looks like? A bowl? Bowl's a pretty good explanation. A bowl with an outer edge that's
like a kiddie bowl.
Like a cone.
Because they don't know how to hold the bowl yet.
A kiddie bowl that's or
like
I feel
a
like
dogfish.
pet bowls. Some look like that, where they're a cylinder on the outside, but there's a scoop out of there for the bowl. So that's what that shape is. That's part of what today is recognizing the shape.
Going back to elementary school, recognizing shapes.
So let's do our template here. Big R squared minus pi little r squared d something.
dy, right?
Why dy?
Because it's going to cross the y-axis.
They're sliced in the y direction. The slices are stacked up in the y direction. Some people actually think about the limits first and then get the x or y, because they feel like they're stacking it from here to here, and those are y values. So some people will actually put the y values in first and then say dy. Other people say, well, it's stacked in the y, so I know it. They go together. So whichever one you see first. All right, so it starts at 0. How far up do we go here?
4.
Yeah, x is
Graph is to be
2.
trusted.
I guess we shouldn't just call it 4. We should call that 2, 4. So from 0 to 4.
How do you plug this into the calculator?
Well, we're not ready for the calculator yet. I need a big R and a little r.
Well, you have to change it
So
from y equals to x equals.
I will have to change it to get them in terms of y, but one step at a time. So big R is from axis to outer edge. Axis to outer edge. So there's big R. And usually we only draw one big R, but it's helpful to think about what is big R, at the start, somewhere in the middle, at the end. So what is big R equal to? It's just 2. It's a constant. It's not changing. The outer edge of this bowl is always 2.
Negative or positive?
The inner R, we already said this thing has a hole in it. So my little r, from axis to inner edge. So the inside circle, the little circle, little r. So little r goes from, we need to slow it way down. We can think about right minus left. Left is 0, so that's kind of nice. So what about this inner edge? What equation is there for that inner edge? X squared. Okay, but, so yes, y equals x squared, but I need something in terms of y there.
X equals square root of y.
So x equals the square root of y. So that means little r is equal to, it's an x value. Maybe we should have started with that. Little r is an x value, so it's the square root of y.
Okay.
Well, we're going to dip into where to put this. Pi, 0 to 4. Big R is 2. Little r is square root of y squared dy.
Okay.
Now it's ready for the calculator.
But how?
So, you mean how do you deal with the y's?
Yeah.
There's two ways to deal with the y's. You can actually type in y's on the calculator.
You can?
So I'll do it that way first because I think that way is the easiest to sort of follow conceptually. So pi times, and you can type it in exactly as you see it if you want to do a little bit of the math just to save you some keystrokes. Like I know what 2 squared is, I'm going to go ahead and put 4. But if you want to be super safe and type in 2 squared, obviously your calculator can handle that. Same thing here. The square root of y squared
Y.
is just y. If you want to type it all in, knock yourself out. I'm gonna go with y. Alpha y dy. Then there's our volume. We let the calculator do the ugly stuff. All right, I'm going to do this next one really quick because it messes some people up. So if you're comfortable typing y's, that's fine. But your calculator has no idea if you're using an x or y or an a or a b or anything else. So if you wanted to, you go math 9 and just say, well, you know what? My calculator doesn't know any better. I'm going to use x because it's just easier to do. You get the same answer. That's not really the picture that you drew.
I don't like it.
I know.
I
Most
don't
people
like
are like, wait a minute, that's not right.
No.
Like, if you don't like it, then
Don't
it's
do
only
it.
a couple extra keystrokes to keep yourself from getting confused. And so spend the time and type in the y's. Whenever I'm doing it, like on my own, like working fast trying for an answer, I'll swap them out. Whenever I'm working in front of you, I will always leave them as y because I think that makes more sense. So ignore all that x stuff if you don't like that swap thing. All right, let's do one more and then we'll go to the candy game. Part E. Find the volume of the solid form by revolving the region. So same region. Around the line x equals 4. Uh-oh. 1, 2, 3, 4 is like off the page here. It's going to make drawing it kind of difficult. There's my axis.
You don't have to do rabbits.
I don't really have to.
There's no hole.
Is there a hole or is there not a hole?
Oh, there's a big hole. No.
There's a big hole, is right.
Looks like a volcano.
Oh, because it's around.
It is a volcano. That's a good description of it. There's a big hole. It's a volcano with a cylinder drilled out of the middle of it.
That's how most volcanoes work, though. They have a big cylinder part. At least that's what the cartoons say.
Oh, I can't move my paper now. Huh? If you want to draw it, you got to get another piece of paper.
Or you
Some people don't want to even draw it. They just know that. Follow the template. So pi big R squared minus pi little r squared.
Would it be the same bounds?
So my slices are. Let's see. Oh, my disc isn't big enough for this, but you get the idea.
You need to get a waffle for it.
You need to get a larger,
1, 2, oh, it's the same thing.
an old record or something. So dy still 0 to 4.
Okay.
Okay, so there is a little r on this one.
Yeah.
Well, there was a little r on the last one.
What's the big R, though?
Big R. Let me draw it first. It's always from axis to outer edge. From axis to outer edge.
Mm-hmm.
So there's big R. Axis to outer edge. I'm going to think about right minus left. All right, you want to find the length of something. Right minus left. Okay, go ahead. 4 minus.
Um,
4's the rightmost part.
yeah, but x squared? Square root of x? Or square root of y?
Yeah, it's got to be in terms of y. So 4 minus,
Square root of
if
y.
we swap that around, that's x equals square root of y. 4 minus square root of y.
This hurts my head, Mr. Wall.
And we didn't say this earlier, but as we go up and down, r changes. So we expect r to have a variable in there, a big R to have a variable.
This time.
Yeah, last time, this is a good contrast to the previous one. Last time the outer r was constant, the inner r was changing. What about little r for this one?
That's constant.
That's just 2. Right? At the top of the volcano, little r is 2. At the bottom of the volcano, little r is 2. So why don't you see if you can set it up and finish it from there while I walk around and hand out cards. See if you can finish it off or put it in the calculator. Every card's a winner. That's a real good one right there.
That's the same. It's kind of hard to figure out the R's without drawing them.
Completely agree.
Because I didn't know that was where the circle was.
Some people can do it. Some people want to draw.
Okay, so how is the bigger the left? So what's the left?
Alright, we gotta speed this up. Take one and pass it back. Take one and pass it back.
So right is
Take one and pass it back.
4, and then X. Okay, that makes sense. Yeah.
Take one and pass it back. Do the 7 of diamonds. Congratulations.
Did I do that right? Because that seems like an awfully big number.
Well, that's a bigger volume than the previous one.
Yeah, but it still seems like an awfully big volume.
Be careful about what gets squared.
But don't you have to add the 2 in there for big R?
This is big R.
Yeah, but you have
It's a
to.
little r. Big R is 4 minus square root of y. Let's see. Math 9. 0 to 4. Pi. Parentheses. 4 minus square root of y. Oops. Alpha y. Keep hitting the wrong button. Alpha y. Close
You still got
parentheses
one.
squared minus pi times 4
dy.
dy.
Brain go ouch.
Oh, you had to make it think on this one. 41.88?
Mhm.
Yes? No?
Mhm.
Okay. Julia.
Wait, how did you get big R again? How is it 4 minus y squared?
So big R is always from axis to outer edge, as opposed to axis to inner edge. So if I want to know how big that is, if I thought about doing this.
4 out.
Yes, this is 4.
Oh, okay.
4 is the rightmost minus whatever this side is.
Oh, okay. Thank you.
Alright, so let me try to explain the candy game here. First time I've done it, so we'll see how it goes.